How are you guys doing? So thank you for taking the time to come to the talk. So as you can see, this is about emotion detection. So
just keep using arrows.
Yeah. Okay. So we all know that emotion is very pervasive in our lives. Emotion is key in our day-to-day communication. It's also very significant for motivating us. So you can imagine things like education motivates us to learn. It's key in our well-being, and it's key in order to get us to do anything productive, basically. So that motivates work on emotion detection, and also emotion is very, I'm having trouble with that. So emotion is very important in public discourse, right? So oftentimes when we see the media talk about, politicians or celebrity and so on, they tend to highlight, how someone, is feeling towards something and so on. So it's also very pervasive in our, media life, in a sense. So in this talk, what we wanted to do is we wanted really to enable deep learning for emotion detection. And what I think you could get out from this talk is like these three messages. Hopefully there will be other things, but these are the keys in the presentation. So first of all, we know that we have a problem. We have the bottleneck of labeled data. It's expensive to label data, it's costly, it takes time, and so on. Especially if you wanted to learn using deep learning, and you want to scale, it doesn't really scale unless you have big amounts of data. So we wanted to do that. We wanted to enable deep learning. Then we used distance supervision to do that. So I'm going to show you how we used distance supervision to acquire state-of-the-art emotion detection models. And we're doing it in two ways. We are detecting 24 different types of emotion, so fine-grained. But we're also kind of falling back to the 8 basic categories of emotion and trying to also predict these. All right, so we all know that also emotion is hard to define, and that's also something that's highlighted oftentimes in the media, right? So what you see here is, journalists talking about how scientists are having trouble defining what emotion is, right? So what is emotion really is something that people, discuss in the academia and so on. So you have this quote, everyone knows what an emotion is until they are asked, basically, and then everybody, no one knows. Okay, and the definition of emotion varies as a function of discipline or approach. So if you're talking to a psychologist, that's probably different from talking to a neuroscientist. And there are also differences within the same discipline. So there are schools in psychology and so on. So there are different also differences within the same discipline. It also varies across time and culture as a function of time and culture. What an emotion was 100 years ago is probably different from what the same emotion means to us as humans today, right? And also cross-culturally. You think about shame, for example, and what it means in a given culture versus a different culture. So, some scholars even cite around 100 definitions of emotion. So with that in the background, we went to the theory and so on. You would find primarily 3 types of models, and there are more, but I will focus on the first 2 here, the categorical models of basic emotion and the bidimensional models. So the categorical models are like these, that's what you see in the media again. Things like anger, disgust, fear, joy, sadness, and surprise. It can go anywhere between 3 to 4 to 6 to 8 types of emotion, and the idea is that these are distinct, and also they are discussed within the psychology as cross-cultural, applicable, universally, and so on. Although this is not, this is not something that everybody agrees on, so there is a controversy there. But the idea here is that we have these categorical models of emotion, And there are also the bidimensional models. Some people try to reduce emotions into these two dimensions, the dimension of valence and the dimension of arousal. So valence, good versus bad, pleased versus frustrated, right? So you can have, emotions vary across this dimension, but also there is the intensity or arousal dimension. So you can be happy and you can be very happy. So that takes you to something like ecstasy, for example, right? So if you take these two models, and before even you do that, so psychologists take that two dimensions and try to give people some words, and then people rate these words and they do factor analyses and so on, and they plot something like this, for example, right? So now I've talked about the categorical models and the dimensional models, right? So if you take both of them, you can plot something like this. This is called the Plutchik wheel of emotion, and it kind of integrates the two ideas of categorical models, but also the bidimensional models. It's, if you haven't seen this before, it's probably very kind of different, and it takes time to know what's going on here. So I am going to kind of scaffold how you read it a little bit. So there are basically, three circles here. So you have the inner circle, let's just call it P1. And that's basically very intense emotions, right? So you remember the arousal dimension? So you have got something like ecstasy, for example. So that's someone who is very happy, right? And then you have got the middle circle, which is, a little bit diluted version of these. And you have got P3, which is the even more diluted version of that. So that's the arousal dimension, right? So we have three, arousal categories integrated in the model. So sleepy versus aroused, as you can see here. So joy can be ecstasy, but it also can be serenity if it's less intense. And you've got the valence dimension. The valence dimension, now we're talking not about joy, but the opposite of joy, right? So someone who is frustrated. So that person can be sad, but if it's too much, then it's grief. But if it is less, then it's a pensiveness, basically, right? So I hope that kind of clarifies what the wheel is about. So it integrates the categorical and the dimensional models, and we use that theory in order to sort of, motivate us, but also in order to operationalize how we model emotion. Now we get to the problem of data. Data is very important, but it's also a problem if we don't have labeled data, right? So what I'm going to do now is to give you some examples of what we call distant supervision, right? So distant supervision, if you read that tweet, someone is saying, I might have had a very busy day, but still thankful for my job. Now watching Bake Off, coloring, and not having any books to mark, #joy. For how many people this comes along as expressive of happiness? Like if you were that person, you were tweeting that. Do you think it's joy? Okay, feel free to raise your hands if you agree. Okay, more or less, yeah. So we get some people thinking that it expresses joy. Of course we disagree sometimes. So the second tweet, in someone who cooked something were not very happy with what they cooked, and you use the F word. Sorry about the language. You pumping pumpkin spice and everything you ruin. #disgusted. Right? Okay, that seems okay, but then not until you meet your angry friends, and then you start seeing people who are using the #angry, for example, not to communicate how they feel, but just in the context of, of something objective. So my kids gets to play Angry Birds to learn basic physics, and she's complaining about it, #parenting. So we think there's a problem there. How do we have something to fix there, right? So that's why we call these hashtags noisy, right? Let's see how we actually kind of went around that problem. So to start off, we put together 650 hashtags for each of the 24 different types of emotion we represent. We developed some hashtags. So for joy, for example, we have happy, happiness, happiest, and so on and so forth. So we collect a lot of data, more than 250 million tweets, and then we take these tweets, we pre-process, so we normalize non-standard typography and so on, like letter repetition and things like that. We deduplicate, we remove retweets. So we do, we remove non-English, anything less than 5 words and so on, so we pre-process. And then we end up with 6.8 million tweets, okay? But that doesn't tell us if the data are good or not. So we wanted to validate this method. So we did an annotation study. We took 5,584 tweets. We gave them to humans, and we said, okay, you will get these data. The data have hashtags. You will look at each tweet. It has a hashtag that, let's say, represents joy. And your task is to say if this tweet really represents joy or not. So if it does, then it's relevant. If it doesn't, then it's irrelevant, right? So it's a binary decision, and we end up with 61% of the tweets, representing these emotion categories. Okay, fair enough, but that's not very much as well. So we go to the next step, which is like, inspired by some of the good research that people have done before. The finding is that, if the hashtag occurs finally, then it's more likely that this tweet will represent that class, right? So we use that condition, we put it on the data, so we end up with 90.5% of the data representing the emotions. Okay, that's like ground truth from humans as labeling these data. But we also lose a little bit in the process, as you see in the numbers. Okay. Then we end up collecting a lot of data like this. These are 24 different, you're not meant to read this, so don't worry too much about it. But we end up collecting a lot of data across the 24 different types of emotion. So for example, if you look a little bit more closely for these 8 first ones, you'll have, the different types of emotion like admiration, amazement, ecstasy, and so on. And then we have the count. And then we have the count when the hashtag occurs in the last quarter of the tweet based on character count. And then we have the count when it occurs finally. So we keep like losing data as we go through that pipeline, as you can see. But we end up with 23% of the data that we judged that are good and so on. So that's very good. So we use these 23%, and we wanted to, so now we know that if we put all the conditions, we will end up with 90%. Based on the human annotation study, we'll end up with 90% good data. So we use these data. And what we did is, okay, so we wanted to compare deep learning models to just traditional models. And because of the size of the data, we wanted to use something like out-of-core classifiers because of memory and so on. So we used 4 of these, as you can see, something like stochastic gradient descent and so on and so forth. And then we used recurrent neural networks, but because of the gradient problem and so on, we put some control flow on top of them, so we end up using gated recurrent units, right? So I'm sure you have seen these a lot, especially in this conference. Okay, so what we do is, we get these accuracies with the online classifiers. So our baseline is 60%. For each of the categories, I call them Pluchik 1, Pluchik 2, and Pluchik 3. We have 3 independent classification tasks. We kind of gain a little bit across all of them. It's not very much, but I know the numbers are very small. So for example, for what we call Pluchik 1, we get 64.8 versus the baseline of 60, right? But then, so these numbers are a little bit bigger. So some gains there. So we want to compare this to the gated recurrent neural networks. And we go like this. As you can see, the F scores go very high compared. So we go from 64.8 to 91 point something. So 26% gain there on Pluchik 1. And then, on the second task, 29%. So on average, we get like 25.4% gain in terms of F measure, across the 3 different categories. Okay. So we get that. We wanted to compare to previous research. There is a lot of excellent research that inspired this work. We couldn't have done this, without all the good insights and findings and so on. We kind of show that if we fall back to the 6 types of emotion that were usually done in previous research, we still gain like 5%. Compared to the previous research. We said, okay, that's good. What we wanted to do is, okay, we will take each 3 different types of, intensities in a given emotion, and then we'll lump these training data, and then we will try to predict. So we'll see what happens there. So we kind of condense the 24 to only 8, and then we train and test on that setup. And we go from, the 80-something, early 90s to 95% F score, which shows, that, basically with more data, you get more gains across the board and so on and so forth. Okay, finally, and that's my last slide. Well, you see, what I have tried to convince you here is that, well, a deep learning needs a lot of data to scale up. We use distance supervision to do that, and it works. That's number one. Number two, we've built the state-of-the-art emotion detection model across 24 different types of emotion, but also across 8 types of emotion. Then finally, when we do that, we get like 95% something F score. By that, I end my talk, and I'm very thankful to my collaborator, Dr. Lyle Unger, who's sitting here. That work couldn't have been possible without him and without the great team that's supporting, both in UBC and in the University of Pennsylvania. Thank you very much.
We have time for questions.
So it was an interesting talk, thank you. I just have a couple of small questions. The first is, how did you get the hashtags, right, that like the list of hashtags that represent, right, the different emotions? So is there a data set available?
Yeah, great question. So in previous research, people have developed a set of hashtags for each type of emotion. We've done the same thing. We discussed them among ourselves, and we validated them and so on. And we used them to acquire data. And yes, the data set, we're very happy to share the data for expediting this type of research.
And how many people, right, agreed on this? How many people constructed this data set? Just curious.
Yeah, it was a group of 5 people, basically. So anything like that, we try to do, we kind of discuss very intensively, because we know that it's a pipeline, and anything that goes wrong somewhere, it will propagate. So that went through very intensive kind of rounds of discussion and validation and so on with people from different backgrounds who are native speakers of English and so on. Yeah.
Okay. So the second question is about word embeddings. Have you used word embeddings in the recurrent neural network to represent the different words in the tweets?
Okay, great question. So for this specific work, I have not. So basically, word embeddings, if you train them off the shelf, like using something like Glove or Word2Vec, they don't capture these semantic pragmatic level phenomena, right? But we do. So there are lots of details in the models. As anybody has used these models know that there are lots of hyperparameters we try to kind of tune and so on, and we did that on a validation set, and we embed we learn end to end. So we have a 300 dimensions embedding learned on these specific data.
So they were not pre-trained.
Yeah. Yes.
Okay.
Yeah.
Okay. Great. Thank you.
Thank you.
Hi, and thank you for your great talk. I do have a question about the evaluation and how have you collected the tweets, or are you using a standard data set of tweets? Because you're comparing your method with other results, and I think everybody's collecting Twitter from different times, and
right.
So how do you compare the results with other methods?
Great question. Thank you very much. I think it's a very valid and very good point. So one of the problems is that if you have collected the data set and I want to replicate your work, I have to go and crawl the tweets using tweet IDs and so on, right? And sometimes you lose some of the data. This is a problem that cuts across the board to any of this type of research. What we did is we had a huge collection, multi-year, and we crawled for 1 whole year as well, so that we capture a lot, as general representation as possible.
Thank you.
Yes, sure.
Thank you for your talk. How is your method handling tweets with no emotion? So I think your data set only contains tweets with like one emotion, but like how would it, if you apply just to all the tweets, like would it correctly identify tweets with no emotion? Does it have like a confidence score or something?
Great question. We don't tackle this as part of the current system, but that's something we're working on.
Okay, thank
yeah.
you.
Oh, so okay. So the question until Dan sets up, the question is like, did you?
He is ready, so really quick.
Okay, so we used as much comparable conditions across the board for the two setups, for the two types of learning and so. So same number of vocabulary and so on and so forth. Of course, in terms of the recurrent units themselves, there are lots of things that you don't usually tune for the other models, right? Yeah.
Sorry to cut the discussion.